On its second day, the ERV deploys a small nuclear power reactor. The reactor powers a chemical plant inside the ERV. The plant will produce the methane-oxygen rocket fuel for the launch home. The long journey to land a human being on Mars begins.
3, 2, 1, engine start.
Carrying the most skillfully assembled flight team in history, 4 astronauts begin their 2.5-year mission to the Red Planet. This will be the first time a human has gone beyond the Earth-Moon system. To counter the health problems of zero gravity and to fully acclimate the astronauts to Mars, the ship will deploy a weighted tether attached to the last stage of the spent rocket booster. By thrusting the ship into a rotational spin, the counterweight of the rocket will create centrifugal force, and thus artificial gravity. The crew will be able to live with their feet planted firmly on the floor during their 6-month transit. On the 6th month of the flight, the crew will gaze upon an alien world. This is the new frontier.
Okay, engine stop.
We're seeing it on the L2 key.
For more than 500 days, the astronauts will live on Mars and embark on one of the greatest journeys of discovery in the history of science. Will they find life? Or the fossilized remains of past life? Such a discovery could tell us whether our solar system has seen more than one Genesis, and answer the ultimate question: are we alone? In any case, these explorers will be learning how feasible the colonization of Mars really is, and whether or not mankind has a future among the stars. Then, when the time comes and the window for Earth return opens, the crew will climb into their Earth return vehicle and head home. They will arrive home heroes, the first to stretch the limit of man's expanse from one planet to another, their names added to the list of great explorers of new worlds. In their footsteps, others will follow. What began as a trickle is free to rise into a deluge of humankind, sweeping over a once barren land and transforming it into a viable new world. When Baker and Zubrin presented Mars Direct to their bosses at Martin, they expected the worst. To their surprise, management was excited about it. They liked the fact that everything needed was relatively simple and near-term.
As time went on, Martin Marietta embraced Mars Direct as their creation and put Bob and I on an airplane to several NASA centers to present Mars Direct and try to build some momentum for it.
Baker and Zubrin flew to Marshall Space Flight Center in Huntsville, Alabama. This had been one of the original design hubs for the Apollo moon landings. Tag team style, Baker and Zubrin presented their alternative mission architecture. The response was thrilling. The old-school Apollo crowd embraced it. This was a plan that actually made sense and was within reach. Over the next few weeks, Zubrin and Baker were flown around the country, pitching to all branches of NASA. And everywhere they went, the response was electric. The plan was standing up to scrutiny, and groups all over NASA were converting to Mars Direct. Their tour culminated in a public presentation to the National Space Society. The crowd gave the two aerospace engineers a standing ovation. A week later, the story was in newspapers around the country. As quickly as doors opened for Zubrin and Baker, they began to close. The NASA administration rejected Mars Direct. The two engineers were outsiders again. But Zubrin remained determined.
Bob had grabbed hold of it, and I could see that it was his, and no matter what I did, he was going to do what he was going to do, and he was going to be a proponent for it and push it. And I really saw my role sort of evaporate. It's a little bit like being a dim planet next to a bright star around him in terms of his enthusiasm, and you really can't compete with that. All you can do is decide how you're going to deal with it.
By February 1991, Baker quit Martin to start his own firm. Zubrin battled on. For the next year and a half, Zubrin tried to get NASA to pay attention, giving speeches, writing papers, but Mars Direct's time seemed to have passed. But then a new administration came into power at NASA. They agreed to give Mars Direct a second look if Zubrin could prove that producing rocket fuel on Mars would work. Zubrin and his team built a machine. It could take carbon dioxide, the dominant gas in the Martian atmosphere, combine it with a little hydrogen, and produce a methane-oxygen fuel.
We did it in 3 months with a very small team. We built a plant that was 94% efficient, and no one who actually participated in that effort was actually a real chemical engineer. They were all aerospace engineers, like me, who were simply dabbling in chemistry in order to prove to NASA that 19th century chemical engineering really worked.
With the new administrator, Dan Golden, getting behind Mars Direct, he had Zubrin give detailed briefings of the mission plan to the engineers at the Johnson Space Center. They liked it, but had some problems. Dave Weaver was the lead mission architect.
There were a number of things that we were concerned about with Bob Zubrin's mission. First of all, we thought his estimates of mass were probably too optimistic. Didn't have sufficient margins for a variety of things.